Hello friends, let's take a look at this one. As always, feel free to pause the video whenever you want and think ahead of me. It's an important thing for you to do is think ahead and not just think along with me, because when you're thinking along with me, I'm the one who's actually doing the work. You are just kind of looking at what I'm doing and seeing if you can follow along. And you doing the thinking is going to be really helpful. All right, let's see what this problem has for us. Traffic flow is defined as the rate at which cars pass through the intersection, measured in cars per minute. The traffic flow at a particular intersection is modeled by the function f, defined by where f of t is measured in cars per minute, so that is a rate, and t is measured in minutes. Now it's important to understand what the function we're looking at is. The function we're looking at is a rate. Since we're looking at a rate, that's already a derivative of something. So if I wanted to know how many cars go through an intersection in some period of time, I would have to integrate that rate. If I want to know how quickly the cars are going through, that would be the cars per minute. If I want to know kind of how quickly that is changing, the cars per minute is changing, that's the derivative. If you relate that to your physics understanding, if that helps, the traffic flow is more like velocity. And so if I integrate, that's more like position, and if I take a derivative, more like acceleration. Now be careful with that analogy, because sometimes when I talk about that, then you can only stay in physics land, and that's not staying within this question. This question is about traffic flow, so I need to make sure I stay within the traffic flow question. I also see that I have a fixed interval. So if I wanted to find a max or a min, that max or min is going to be where, say I wanted to find a max or min of, I don't know, the traffic flow. I would have to take the derivative of f of t and then set that derivative equal to 0. It's never going to be undefined because it's a sine function. And wherever that is 0, those could be my maxes. And I also have to consider my endpoints. And if I wanted to find the max for the number of cars through the intersection, I would just look at the traffic flow and set the traffic flow equal to 0, and then consider the endpoints. Although the traffic flow would never be 0, because we have an amplitude of 4, and we start at 82, so we're way up in the sky there. All right, let's look at what we got. Traffic flow, we got f of t to the nearest whole number, how many cars pass through the intersection over the 30-minute period. So that means I need to integrate from 0 to 30 the traffic flow, and that will get me how many. So if I'm using a calculator, I would suggest you put that traffic flow equation into your calculator, because I bet we're going to need it in more places than just this. And then you can reference it using it like y1 or whatever, however your calculator does it. And if I'm putting this in my calculator, I get 2474.078. So there are 2,474 cars through the intersection. Over the 30 minutes. All right. Next one. Still we got the traffic flow. That's still a rate. That's a rate. Is the traffic flow increasing or decreasing? So this is saying, is f of t increasing or decreasing? Well, to talk about that, I need to look at f prime of 7. This is a calculator question. So I can just, into my calculator, write down, okay, what is the derivative of f at 7? And when I ask my calculator that, my calculator says negative 1.873. It's 293. And so the traffic flow is decreasing at t equals 7, because f prime, f prime at 7 is less than 0. So since we have a negative derivative, that means my function f is decreasing. So it's a little confusing because it says traffic flow increasing or decreasing. So you might just think of, I just look at f of 7. But that's just telling me is the number of cars increasing or decreasing. But I want to know is the flow increasing or decreasing. So that's the derivative of the flow. Part C. What is the average value of the traffic flow over the time interval 10 to 15? So to find average value, don't confuse average value with average rate of change. Average rate of change is an Algebra 1 or a average slope question, whereas average value is a calculus question. To find the average value, that's basically saying, okay, I have this curve f of t, whatever it looks like. What's the average f value over this interval? Now, that's not to say what it looks like over the interval, but what's the average value? So to find the average value, what I want to do is I want to integrate from 10 to 15, 10 to 15, f of t dt. And then because it's an average, I need to divide by how wide that interval is, which is 15 minus 10. And I'll have a discussion about that in a minute. But let's calculate what that is so that you can figure out if you did it correctly. So go back to my calculator, put this information in, and I get 15 and divide by 15. Oh, I didn't like that. I'll do 1 over 15 here. Not 15, 5. 1 over 5. There we go. So I got 81.899. And I forgot the period. And then that is in, so I integrated, so that gets me up to cars. And then I divided by minutes. So that's still in cars per minute, which makes sense because that's the average value of the traffic flow equation. So that's the average function value of the traffic flow equation. Now, let's have a little discussion here. Let's pretend I were able to integrate f of t. So let's say the underivative of f of t is, let's see, it's traffic, right? Is cars. So let's call it big C. So c of t, let's say that's the underivative of f of t. And I'm integrating that, or I'm evaluating that from 10 to 15. So that's c of 15 minus c of 10. But I'm dividing that by 15 minus 10. I'm dividing that by 15 minus 10. So if you look at this, that should make you think of something. That is the average rate of change of the number of cars through the intersection. And then you divide that by time. So the average rate of change of the number of cars through the intersection over that time interval. I ran out of room, so I just said the rest of it verbally. So the average value of f, of the derivative, is the average rate of change of the step up from that, the underivative. Interesting connection, helps with units, because this is in cars, and then this is in minutes, so cars per minute. But I don't have to actually figure out what the function is for c of t. I could actually, because it would be like 82t plus minus 8 cosine t over 2. But I don't need to figure that out. That is not what I'm asked to do here, and it's a calculator question. And part D, what is the average rate of change, so now we got the average rate of change, of the traffic flow over the time interval 10 to 15. Now, this is of the traffic flow, so I want to find f of 15 minus f of 10 over 15 minus 10. So again, I go to my calculator, and I ask it, okay, what is f of 15, that's 85 and a bit, and then f of 10, and then I divide that by 5, and I get 1.518 8, and now my units. So this is the slope of the traffic flow. So that's in cars per minute, or per minute squared. And that's all I need to say there. So they're trying to make sure we understand the difference, both in units and in concepts, between average rate of change and average value. There are big distinctions there. They're trying to make sure we understand that. The whole question. Okay, the whole question. So we're given a traffic flow function. So this is a rate. We're given a rate. So the rate of cars through the intersection. And for part A, we just need to figure out how many cars go through the intersection. So we just add up all of those rates. So we integrate the rate. And then is the traffic flow increasing or decreasing? So traffic flow is known as f of t. So that's just taking the derivative and looking at what that value is. Since I have a calculator, I don't have to actually calculate the derivative, which I could do. But I don't have to actually calculate the derivative because I'm simply being asked to evaluate it on my calculator. And then the average value, that means add up all the y values and divide by kind of how many there are. But in this case, it's use the integral to find, I guess, the area under the curve, you could think of it that way, and then divide by how wide that interval is. And then the average rate of change is just an average slope question, which you could have answered in Algebra 1. Let's see how we did. We integrated, got 2,474 cars. We took a derivative, got a negative number, said traffic flow is decreasing. We found the average value, and then we found the average rate of change, and we used our units correctly. And that's it. If they had a question like this now, there would be some more stuff to it, I bet. This seems like it's not quite enough for questions now.